The B-17 Flying Fortress, a name that evokes images of World War II. This bomber became a symbol of American might. It was a testament to industrial innovation. The B-17 was designed to deliver destruction. It carried a heavy bomb load deep into enemy territory. But this aircraft was more than just a weapon. It represented resilience. It embodied the courage of the young men who flew it. The B-17 was built for daylight bombing raids. These were extremely dangerous missions. The skies over Europe were a deadly place. The B-17 faced relentless attacks, yet it persevered. The B-17 story is one of innovation and sacrifice. It is a story of technological triumph, and it is a testament to the enduring human spirit in the face of adversity. Thousands of these aircraft were built during the war. They flew countless missions. They helped to turn the tide against the Axis powers. The B-17's impact on the war was significant. It helped to cripple the enemy's war machine. This iconic aircraft played a crucial role in securing Allied victory. The B-17 was known for its ruggedness. It had a remarkable ability to absorb damage and keep flying, but it was not invincible. The B-17 had a critical weakness. Its tail was vulnerable. Understanding why requires a closer look at the aircraft's design. We also need to grasp the basic principles of aerodynamics. The tail of the B-17 was not just an afterthought. It was an engineering marvel. It played a vital role in the aircraft's stability and control. The tail consisted of several key components. These included the horizontal stabilizer, the vertical stabilizer, and the rudder. Think of the tail as the feathers on an arrow. It kept the plane flying straight. The horizontal stabilizer provided lift. This counteracted the downward force of the nose. The vertical stabilizer acted like a fin. It prevented the aircraft from yawing. Yawing is the side-to-side movement of the nose. The rudder attached to the vertical stabilizer controlled yaw. The B-17's tail was a complex structure. It needed to be strong. It had to withstand tremendous aerodynamic forces. But there was a delicate balance. Engineers wanted a strong tail, but they also needed it to be lightweight. A heavy tail would reduce performance. Designers faced challenges. They used strong but lightweight materials. They employed innovative construction techniques. The goal was to create a tail that was both robust and efficient. Despite these efforts, the B-17's tail remained a point of vulnerability. Combat damage could have catastrophic consequences. Even minor damage could affect flight characteristics. This made the aircraft difficult to control. In some cases, tail damage led to complete loss of the aircraft. To understand the B-17's tail failures, we need to talk about air. Air is not empty space, it's a fluid, like water. Just as a boat moves through water, an airplane moves through air. This movement creates forces. These forces are lift, drag, thrust, and weight. Lift is the force that opposes weight. It's what keeps the plane in the air. Wings generate lift by changing the direction of airflow. Air flowing over the curved upper surface of the wing travels faster than air flowing under the wing. This difference in speed creates a difference in pressure. The lower pressure above the wing pulls the wing up, creating lift. Drag is the force that opposes thrust. It acts like friction, slowing the plane down. Drag is caused by the shape of the aircraft. A streamlined shape reduces drag. Thrust is the force that propels the plane forward. It's generated by the engines. Weight is the force of gravity acting on the plane. The tail plays a crucial role in balancing these forces. It ensures stability and control. Damage to the tail disrupts this delicate balance. Section 4. Stress fractures and metal fatigue, the unseen enemy. The B-17's tail wasn't just threatened by enemy fire, it also faced a hidden danger, metal fatigue. Metal fatigue is like the tiredness you feel after a long day. Except for metal, this tiredness can be deadly. Imagine bending a paperclip back and forth. It will eventually break. This is metal fatigue. The repeated stress of flight, especially during turbulent conditions, could cause tiny cracks to form in the metal structure of the tail. These cracks, invisible to the naked eye, would grow over time, weakening the tail until it could no longer withstand the aerodynamic forces acting upon it. Several factors contributed to metal fatigue in the B-17's tail. The constant vibrations from the engines, the stress of high-altitude flight, the repeated cycles of pressurization and depressurization. All of these took their toll. The B-17 was designed for a certain lifespan, but the demands of war often pushed these aircraft beyond their limits. Maintenance crews worked tirelessly to inspect for and repair signs of metal fatigue, but it was a constant battle against an invisible enemy. Section 5. Under enemy fire, combat, and the fragile tail. The skies over Europe were a dangerous place for B-17 crews. German fighters were a constant threat. They were armed with cannons. These cannons could inflict significant damage. The B-17 had multiple gun turrets for defense, but it was still vulnerable to attack. The tail was a particularly vulnerable spot. It was a large target. It housed critical control surfaces. Damage to the tail could have dire consequences. It could cause a loss of control. It could lead to a spin. In some cases, it could result in the tail breaking off entirely. There are numerous accounts of B-17s sustaining tail damage in combat. Sometimes, the damage was minor. The aircraft could return to base safely. Other times, the damage was catastrophic. The aircraft would be lost, along with its crew. The experience of the B-17 highlights the vulnerability of aircraft in combat. It underscores the importance of robust design, and it emphasizes the need for effective defensive measures. Section 6. Lessons etched in the clouds, the legacy of the B-17's tail. The B-17's tail, despite its vulnerabilities, taught us valuable lessons. Lessons that continue to shape aviation today. We learned about the importance of material science. We gained a deeper understanding of metal fatigue, and we saw the critical need for redundancy in aircraft design. The B-17's experiences led to improvements in aircraft construction. New materials such as aluminum alloys were developed. These materials were stronger. They were more resistant to fatigue. Designers began incorporating redundancy into aircraft systems. This meant that if one system failed, another could take over. The B-17 also highlighted the need for better pilot training. Pilots needed to understand the aircraft's limitations. They had to know how to react in emergencies. This led to the development of more rigorous training programs. These programs emphasized flight safety and emergency procedures. The lessons learned from the B-17 extended beyond the realm of engineering and pilot training. They also influenced the development of new tactics and strategies. The use of fighter escorts, for example, became standard practice to protect bombers from enemy fighters. Section 7. Soaring to new heights. B-17's impact on modern aviation. The B-17's legacy lives on in modern aviation. The lessons learned from its design and operation continue to influence how we build and fly aircraft today. We owe a debt of gratitude to the engineers, pilots, and crews who pushed the boundaries of aviation during World War II. Modern aircraft are equipped with sophisticated systems to detect and prevent metal fatigue. Advanced materials and construction techniques make them stronger and more resilient. Redundancy is built into critical systems to ensure safety. Pilot training programs are more rigorous than ever. They utilize advanced simulators and training aids to prepare pilots for any situation. The emphasis on safety and crew resource management has significantly reduced the number of accidents. The B-17 may be a relic of the past, but its impact on aviation is undeniable. It serves as a reminder that innovation often comes at a cost, and that the pursuit of progress requires courage, ingenuity, and a willingness to learn from our mistakes. As we look to the future of aviation, we carry the lessons of the B-17 with us. These lessons will continue to guide us as we reach for new heights.